Hello, greetings to everyone. My name is Jesus Diego Tuero-Odonnell Zulaica, and I'm going to present the work titled Changes in Critical Thinking Through Philosophical Strategies in Quantum Physics Education, related to my doctoral research in educational physics, which belongs to the National Polytechnic Institute of Mexico. I am applying this research at a Colombian university where I have worked for the past few years and where some initial results have already been obtained. This research is being supervised by Dr. José Gilberto Castejón Mendoza and Dr. Pamela Geraldine Olivo Montaño from the National Polytechnic Institute and the Monterrey Institute of Technology, respectively. A common problem that educators face is school dropout and course cancellations, which can occur for various reasons. One of these is the inadequate development of critical thinking skills, especially when applied to subjects that introduce paradigm shifts, such as modern physics. This challenge is further compounded by students' weak mathematical foundations and the lack of originality in teaching strategies typically offered by educators. Therefore, the central problem identified in this research is the low level of critical thinking with which students enter university. Quantum physics serves as an ideal field to explore original methodologies that do not emphasize mathematics, but rather out the full critical potential of students. This can be achieved by fostering underutilized practices such as philosophical reflections and Socratic debates, which are highly effective in addressing paradigm shifts and conceptual changes when transitioning from classical to modern physics. In the literature review, I focus on four main areas: critical thinking, teaching strategies for quantum physics, the role of philosophy in education, and conceptual change theory. Regarding critical thinking, it is considered one of the key educational skills of this century. However, it has been defined in various ways, often relying on quantitative instruments that use close-ended questions. Regarding quantum physics education, there is a notable lack of strategies based on alternative interpretations, with studies being mostly limited to the standard Copenhagen interpretation. Furthermore, existing assessment tests fail to link learning in this field with different levels of critical thinking, typically focusing on conceptual gains rather than qualitative interpretation. As for philosophical methodologies, they have been applied to students of all ages, though generally in a superficial manner. Finally, conceptual change theory remains relevant and has been studied in the transition from classical to modern physics. Recent modification has shifted away from eradicating prior concepts, instead emphasizing the coexistence and evolution of ideas, particularly when learned meaningfully. Based on these findings, the research was designed with the general objective of qualitatively assessing the evolution of critical thinking skills achieved through the primary resource of philosophy among university students encountering wave-particle duality for the first time in engineering programs at a Caribbean university in Colombia over a 4-week period. The theoretical framework of this research was divided according to the relevant disciplines. For critical thinking, the study referenced Bloom's taxonomy, that is, knowledge, comprehension, application, analysis, synthesis, and evaluation, as well as the categories proposed by Cano Alvarez, who offer a practical application of this taxonomy. The philosophical component was based on Schumacher's philosophical didactics and the Socratic debate technique. Quantum physics concepts included both the Copenhagen interpretation and alternative interpretations. Conceptual change theory was framed within the theoretical model proposed by Moreira and Greca. And for interpreting student responses, a qualitative content analysis approach was adopted. The methodology was based on the design of a 10-session instructional sequence, each lasting 100 minutes. Each session begins with a video or a reading of a popular science article related to quantum principles or another thought-provoking topic. This part lasts 30 minutes. Next, a Socratic dialogue is conducted, lasting 40 minutes. Finally, students answer open-ended questions related to the session's topic in writing for about 30 minutes. The complete instructional sequence can be accessed at the link provided in this session. The recommendations from the Inter-American Teacher Education Network, published in their document titled Critical Thinking Toolbox, were followed for drafting questions based on the specific critical thinking skill being assessed, as well as for planning classes and conducting Socratic debates. Qualitative analysis was carried out using deductive categorization, meaning that predefined categories were used to code student responses. These categories combined Bloom's taxonomy with those used by Canon Alvarez, resulting in the table shown in the image. Additionally, each category included an extra classification: positive for profound, meaningful, or accurate responses, and negative for superficial, insignificant, or inaccurate responses. For its final category, records of positive and negative assessments were extracted, and the calculated ratio is displayed in the image to analyze its evolution. The qualitative analysis software Atlas was used to code and categorize student responses. 2 pilot studies were conducted in 2023, initially with 40 questions and a final test. These trials helped refine the instructional sequence and better adjust time allocation. It was ultimately decided to focus critical thinking assessment on higher order skills, that is, analysis, synthesis, and evaluation, as lower level skills are better developed through traditional methodologies. Additionally, the final test was eliminated, and it was deemed unnecessary for tracking session by session progress. The final instrument comprised 24 questions, with 8 for each of the 3 highest critical thinking skills. This version of the instrument underwent expert validation, where judges assessed the coherence, relevance, clarity, and sufficiency of the questions. The Aikens-V statistic was used to measure judge agreement. After some revisions and eliminations, the final version consisted of 21 open-ended questions, with 7 for each of the 3 highest critical thinking skills. In 2024, the didactic sequence was implemented using the validated instrument, and the process of categorizing and coding responses began with the support of the qualitative analysis software Atlas. The attached graph presents the evolution of the critical thinking ratio for each of the 3 assessed skills, allowing for initial conclusions to be drawn. These findings will later be integrated with the field notes recorded during the sessions. The skills of analysis and synthesis exhibit a similar pattern, showing an upward trend after the first 2 sessions. This is particularly evident in the first skill, represented by the blue curve, which displays a steady progression. This trend can be attributed to improvements in the ability to analyze elements, principles, and relationships, although significant differences between individuals were noted, as documented in other reports. Regarding the evaluation skill, from the very first session, a tendency to rely more heavily on internal rather than external criteria was observed, posing a potential risk. Additionally, opinions were often maintained with minimal justification, resulting in superficial assessments. The progression of subsequent sections did not reveal a clear trend in the evaluation ratio, as shown in the graph. This suggests that the debate topic had a significant influence on the evaluation scales employed by the students, an effect not observed in the case of the other skills. In 2025, a deeper exam of the obtained results is planned, using content analysis techniques, coherence tables, Sankey diagrams, and field notes recorded during the sessions. Thank you for your attention.